Jumbo, this is our introductory PowerPoint to chemical formulas. And so it's talking about formulas in general. In future ones, we'll talk about ionic and covalent compounds. So formulas, we like them because they are a much simpler way of communicating information about the chemicals we are dealing with. They tell us in a simple fashion the number of atoms of each element in a compound. So here we have a compound. It says Al2S3. If we were in English class, we would write, oh, I have 2 atoms of aluminum and 3 atoms of sulfur. It's a lot easier to go Al2S3. Chemist looks at that and automatically knows what's going on. So we put in the element symbols from the periodic table, and then sub means below, so subscripts are numbers written down low that tell us the number of atoms of each element. Sometimes it's hard to picture what these things represent. So if I look at NaCl, that's 1 atom of sodium and 1 of chlorine. So it might look something like this when we represent them as balls combining. The sodium will have shrunk in size because it lost an electron to become an ion, and the chlorine will gain an electron and gets a little bigger. Here's one you're familiar with. There's Wawa. And so you see you have the bigger oxygen atom and you have 2 smaller hydrogen atoms. Hey, makes sense. 2 H's for every 1 O. And that would be a molecule. Now we're looking at an ionic compound. It won't be exactly like this, but for this course, this is a reasonable way to represent it. It's saying that we have 1 barium and we have 2 hydroxides. But each hydroxide is an oxygen bonded to a hydrogen. So that 2 actually applies to everything in the bracket. So 2 oxygens, 2 hydrogens look something like this. So here's our barium. Here's an oxygen, hydrogen, and on this side, another oxygen, hydrogen. So compounds are forming when we get 2 or more different elements coming together and chemically combining. Hexane is C6H14. So a lot of carbons, and we'll see when we do organic, carbon likes to form the backbone of many organic compounds, and hydrogens fill in on the outside and look something like this. Whoa. So if you do some counting, you can quickly see the backbone is 6 carbons, and you can count and find the 14 hydrogens on the outside. So it's nice if you can go from a formula and visualize what's going on, and that takes practice. Chemistry will make a lot more sense.